going to do is we're going to go back and look at, let's see. Oops, sorry, I got the wrong thing here.
Teacher,
What's that?
who's bullying? Probably not.
Okay, so let's go back and look at what we had here. If two lines, we did this yesterday, if two lines are perpendicular, then they intersect. Remember that from yesterday? We talked about it and we said, I asked you guys to create, I asked you guys to create a, what do you call it, an if-then statement out of that. So what I want to do today then is kind of go back over that and talk about the other different ways that you can write that statement. So one of the things that we do is that when we start talking about what we call our conditional statement, if two lines are perpendicular, then they intersect. That is our, going back from yesterday, our P implies Q. Remember that? This is what we call our conditional. And we wrote it like that. The reason that I'm using this P and Q is because I want us to get to the idea of the actual logic way of writing things out. Now, what I'm going to do next is what's called the converse. The converse of the statement is basically saying it backwards. Okay? What I'm going to do here is called the converse. The converse switches the P and Q. So converse says Q implies P. So if I look at the statement that we have, if two lines are perpendicular, then they intersect. So if I rearrange that to the what we call the converse, what I would then say is if two lines intersect,
Then they are perpendicular. Not necessarily.
good, and you're coming right away with the counterexample.
Sorry.
That is how you say it backwards. And just like Caleb just said, that is a false statement.
So wait, so can this work both ways?
What do you mean?
Converse? So, say if something is already false on the, when it's not in the converse, there's the conditional. So say if it's false in the conditional, so the converse can make it true.
Yes.
Sweet!
Okay.
I learned something.
A lot of these things here, guys, when we utilize this whole logic way of writing it out, it's just a matter of flip-flopping values and putting the word not in them. So the next one is the inverse. The inverse what's that?
I said everything's spelled backwards. In the inverse. I was just kidding.
That was
Oh.
You say it's upside down.
Got all right, man.
You whiskey over here, singing gospel music.
Exactly. What is that? Sometimes you'll see it written like that. It looks like a backwards upside down 7.
Whiskey, did you
Sometimes-
count your days of the week again?
Stop. Remember we talked about this a second ago. Inner monologue. Paper, pencil, write things down. Thank you. When we work through stuff like this, there are multiple ways to write this out. What we can do is we can use this kind of like a sideways upside down 7, or sometimes it's written as a tilde,
What is
a single squiggly. In logic, this stands for not. It does, doesn't it? We're trying to make ourselves seem cooler than we are. So what we do here is we negate our original statement. Not P implies not Q. So our original, if two lines do not, or if two lines are not perpendicular, if two lines are not perpendicular,
They are parallel.
then it's not what the thing says. Then they do not intersect. I put the word not in both of the original statement.
Wait, so,
Give me 1 second, okay, please. Write this down. You need a pencil. Come on, let's go. Write these down then. If two lines are not perpendicular, then they do not intersect. Now, a second ago, we had done converse, inverse, and the conditional. Our conditional is the generic, our first statement. P implies Q. Converse, you flip-flop. Q implies P. Inverse, you put the word not in both the first statement and both parts. And then the last one, what do you think we're going to do? Well, see what we did here. We flip-flopped them right away. We went back to the original and put the not in them. Flip-flop them and put a not in it. That's called the contrapositive. The contrapositive is the not Q implies not P. You negate the back half, which implies that you've negated the front half. Yeah, so it's not Q implies not P.
Oh, so.
So basically you're going back to your converse. If two lines do not intersect, then they are not perpendicular. Bless you. Okay? This section has a little bit more writing than what you've been doing for any other math class before. Because you're going to rewrite statements to show true or false versus each one of these four. Now, the one thing that we have not done here, which we will start to do as we go through each one of these statements, is to say whether or not each one of them is true or false as we're going along. If they're false, what we're going to do is put a counterexample in right away. And we'll do that again here in a second with another very simple example. So if I look at it, our first statement was, if two lines are perpendicular, then they intersect. True or false?
True.
Oh, wait, no, it's true.
True.
If two lines are perpendicular, they have to intersect because they have to form a right angle. Okay?
Yes.
We know that right there
It's true.
is a true statement. Then we go to the converse. If two lines intersect, then they are perpendicular.
False.
False. That's false because what would be my counterexample? What's something I can draw real quick? An X. But do I want it like a X, or I just want to? I can do this because they don't have to be perpendicular. All right.
Oh, you forgot to put your arrow or something. Can you draw what? That's the angle.
I got you.
a Y?
Okay. If I draw the Y, then I'm showing that it's a line in an array. By putting it through and throwing my arrows in, and I know that's two lines that I'm showing. Okay. If two lines are not perpendicular, then they do not intersect. Is that true or false? That's also false. What do you think your counterexample could be? Exactly. A lot of times you're going to find that. We're going to be, a lot of times your counterexample that you use, you might be able to use more than once. Yeah. Good times. And then lastly, if two lines do not intersect, then they are not perpendicular. That's true. Very good. That's true. Okay? So a lot of times what happens with these statements is that if the pattern holds, I don't want to say true, but if the pattern holds out, you're going to start to see that your first and your last usually are true. The middle ones can be false. There are times when all of them are true. There are times when sometimes all of them could be false as well, but more often than not, we can do it this way. Okay? Should we do another one?
Yes, please.
All right. Do another one. We did this one. We'll do one like this. If angle A is 100 degrees, then it is obtuse. So this is our conditional statement. P implies Q. That's your conditional.
That's, I believe, is false.
If angle A is 100 degrees, then it is obtuse.
True.
True or false? True. Obtuse angles measure more than 90 degrees. So I know.
More than 90 degrees and less than 180.
Correct. I know that's true. The next one is our converse. The converse, remember, the converse just flip-flops them. If I flip-flop that, what do I say?
If an obtuse angle,
It equals 100. Yeah, we'd have to equal 100. So if, and,
that's false.
oh, it's me right here. If angle A is obtuse, then it measures 100 degrees. Whiskey.
False.
False. Counterexample.
We can have 116.
Very good. It is false. The measure could equal 116 also.
Or it could be like.
There are multiple ways to use. There's multiple counterexamples. Remember from yesterday, how many counterexamples do you have to have in order to negate something? Just one. Just one. Okay. The next one was the inverse. The inverse was the not P implies not Q. Not P implies not Q. So that means you go back to your original statement. Your original statement said if angle A is 100, so now I would say if angle A is not 100. You guys have used that before. The equal sign with a slash means not equal. You've all seen that, right? If angle A is not equal to 100, then it is not obtuse.
I object.
Okay, what's your counterexample?
Oh. Okay, if it's not 100, it could be as much as 360 or even 0 degrees.
No. We're talking about it, then it is not obtuse here.
Then it
So-
have to be acute or.
Oh, I'm sorry. I see where you're going with that. Okay. Yeah. Since what you have here is that we're talking about the obtuse, usually people start thinking that we're looking at the non-obtuse. So if you're saying the angle could measure 16,
Yeah, like it could be like acute or it could be like as much as like 359, like opposite of obtuse or something.
yeah, and you're on the right track there. But remember, in geometry, you're only going 0 to 180. Don't worry about the full 360 stuff. You don't deal with anything over 180. Okay? Don't worry about that in this class. All right? So, a counterexample is it could be any other angle measure, which means it could be an acute angle, it could be a right angle. You could still say that it's if it was 115 degrees again, Well, that negates it's your counterexample, then it would have had to have been obtuse, all right? A lot of times you'll start to see that the two counterexamples that you use in the middle, you can kind of use the same one a lot of times. Okay? And then lastly, going to the last little bit was the contrapositive, and I'll rewrite all these out again for you. Was the not Q implies not P. Did I flip flop like that in my mistake? Okay. So it's betting you. Actually, we didn't do this the past 2 years. So why? We changed around a lot of the curriculum in geometry, and we, with all the newer stuff that we're supposed to be doing and all, and the past 2 years it's been really rough as far as a lot of the logic stuff that we do have to cover. And when we get to proofs, students have had a pretty hard time. So this past year, going into this year, we decided that this would be a really important section, this one and a little bit more of the algebraic stuff that we're going to do next week. It's really important so that when we start to do the geometry, triangle proofs and stuff like that, you'll have a little bit more background of the logic reasoning parts. So we thought that maybe bringing this back for a couple of days wouldn't be a bad idea. So that's why we brought it back. And believe it or not, math teachers forget stuff if you don't use it for a couple of years. I'm not lying. It does happen. I hate to burst your bubble. We do have to. I know. I'm sorry. There's a lot of things that, when I go back in my algebra class, we start talking again about logarithms and stuff. I have to reteach myself logarithms because you don't use them all year long. You got to go back and remember how to do it. So, or pre-calc. Geez, when I taught pre-calc last year, I had to remember how to do like everything. I had pre-calc class in a few years. So not Q implies not P then would have been, if angle A is not obtuse, then it does not measure 100 degrees. If angle A is not obtuse, then it measured not equal to 100. True or false? True, very good. That's a true statement.
Because it's not equal to 100 degrees.
If it's not obtuse, it's not going to equal 100 degrees. So that's a true statement. So again, a lot like I was saying, a lot of times your first and your last wind up being workable values. Okay? They wind up being very workable values. Let me give you guys one. Let you work on it, and we'll check them here. But I'll leave up the not parts and see what we can do. Oh, let's see.
Yeah. So.
Here is your conditional statement, okay? Here is your conditional statement. What I'd like you guys to do is to go through and take a second and try to write it out in the other three formats. Remember, your conditional statement is your P implies Q, converse is X. Yep. You're going to be given conditional. Okay, you're going to be given the conditional statement. The inverse was not P implies not Q. Well, we're not using the word puppy. We're using the word dog.
Doggy.
So let's assume it's an adult dog.
Oh. I mean,
So this is your P implies Q, so Q implies P. If a dog is large, then it's a Great Dane. False. Why is that false?
Because other dogs are tall.
The other dogs are big. I got a black lab that's 90 pounds, so yeah.
I got a dog that's
Okay.
that's crazy.
So then we have not P.
I got comments.
It's mouse dog.
So not P to not Q for your inverse. If a dog is not a Great Dane, then it is not large.
It's the same.
Yes, I just copied and pasted that onto the board because I didn't want to write it out.
Lazy.
All I did is put the word not in there.
Lazy.
Convenient.
That means it's still false.
True or false? Still false. What's the, can I use the same counterexample?
Tech savvy.
I'm something. And then not P implies, excuse me, not Q implies not P.
Dog's not large.
If a dog is not large, then it is not a Great Dane.
Oh, wait.
Oh.
Wait, I
It could be a midget dog.
Now, there's a level of ambiguity when you come to certain parts like this, and you have to kind of take a little bit of a grain of salt. What they're talking about here, if it's not a large dog, then it's probably not a Great Dane. And that's why I would say that would be a true statement. Yes, I know that you can have smaller Great Danes. It could be a Great Dane, you know, pup. But we're talking about adult dogs. Okay. There is, excuse me. Excuse me. We kind of ran out of time for one last definition. We'll do that tomorrow before we get to our logic puzzles. It's very simple. It's called a biconditional statement, but I'm trying to think what the homework, I think I already put it on, did I put it on the calendar or no? It's not on the calendar? Okay. Let me grab my notepad, I have it written on there. I might have to adjust it because we did not talk about the biconditional statement, which is not a big deal, it only takes a second to do.
Watch out, this comes about to throw something.
So this is going to be on page, it's going to be on page 83, same section, 2.2, and I have it going 7 through 10, but I think that's the biconditional ones. Nope, that's all right. 7 through 10, and then all right, so we're going to do 7 through 10. That is all of the P to Q, Q to P, not P, not Q, not Q, not P. That's those. And then 22 through 25. Okay? I took out the 4 questions about biconditional. That we'll worry about that tomorrow. It's really simple to do. All right, we'll get that going for tomorrow. We'll go through them, check how you do with your write-outs. When you guys are writing those out, do me a favor, guys. Do me a favor. When you're writing those things out, off to the side, write down what each one of them are. The first statement they're going to give you is just a generic statement. They don't give you the conditional. You're going to come up with it. It says the complementary angles add to 90 degrees is the statement. You would have to turn that into an if-then. If two angles are complementary, then they add to 90. That's what you would come up with as your conditional. If two angles are not 90, then they are not complementary. If two angles don't add, or if two angles are not complementary, then they're not 90. You go through all of that. Okay? That's what you're going to be doing. Logic, no math. It's just logic. All right? No, that's a completely different thing.
So we have a problem.
Yes, sir.
The great thing.